Okay friends, in this session I'll give you tips to crack the questions on clocks. Probably this is one variety of question which you are going to handle in this video, and that is, let's say you have been given a time. Let's say you have been given 3:15 AM or PM, and you're supposed to find the angle between minute and hour hand at 3:15 PM. Fine. So as a layman, you will end up getting, you can say that the answer is 0 degrees or 90 degrees or so on and so forth. But there has to be some logic behind solving these kind of questions. So whenever you will be asked to find the angle between a particular time, let's say at 3:15. So you start with the very basic. Let's say you assume to be an integral r. So the nearest integral r, which is close to 3 PM, is 3:15 is 3 PM. So you know that what is the position of minute and hour hand at 3 PM. This is what it is. There is an angle of 90 degrees at 3 PM. This is your minute hand and this is your hour hand. Now you know that distance is equal to speed into time. Now additional time that we are talking about is 15 minutes. So for this 15 minutes, minute hand is going to travel for 6 degrees per minute, and hour hand is also going to travel for this 15 minutes at a speed of half degree per minute. So the distance that minute hand would have traveled in 15 minutes will be 6 into 15, which is 90 degrees. That means after 15 minutes, minute hand is going to come at this position, which is at 3. So from here. And during the same time, the distance that the hour hand is going to travel will be 15 time and into half, which is its speed, which will come out to be equal to 7.5 degrees. So from its existing position, which was at 3, it will move 7.5 degrees. So the effective distance between minute and hour hand at 3:15 will come out to be 7.5 degrees. So this is how you are going to solve these kind of questions. Let's take another example. Let's say my question would have been, what will be the angle between minute and hour hand at 3:45? So as I told you, the first and foremost thing that you need to do, I'm not going to tell you any formula because there's no point in remembering formulas because it's a concept driven thing. So you start with the nearest integral r to 3:45, so start with 3. So this is the position of minute and hour hand at 3. The additional time that I am talking about is 45 minutes. In this 45 minute hand is going to travel a distance of, let's try to find the distance that minute hand would have traveled. Speed of minute hand is 6 degrees per minute. Time that we are talking about is 45 minutes. So 45 into 6 will come out to be equal to 270 degrees. So at 3:45, minute hand is going to come at this position. So this is a new position which minute hand would have attained from here to here. Within these 45 minutes, distance that hour hand would have traveled would have been 45 into half, which is nothing but 22.5 degrees. So it would have traveled from here till here. This is 22.5. And what you are supposed to find is this effective distance, this new effective distance, which is going to be, if you look at from this point of view, which is going to be 270, this entire thing, minus 90, minus 22.5. So if you solve this, it will come out to be equal to, or you can also look at this with 30, 30, 30, 30, plus 30, which is nothing but 1, 2, 3, 4, 5, which is nothing but 150, plus 7.5. So your answer will come out to be 157.5 degrees. So this is how you are supposed to solve these type of questions.